Hey there, chemistry enthusiasts. Welcome back to the channel. So hydrogen's the smallest and simplest element on the periodic table, but did you know that its exact position has been the subject of debate for over a century? Today, we're diving into the fascinating and complex world of hydrogen's true position on the periodic table. Where exactly does it belong? The placement of hydrogen on the periodic table has been debated for decades. Traditionally, it sits in group 1, but over time, many scientists have proposed alternative locations. So, why is its position so controversial? To understand why hydrogen's position is so puzzling, let's first take a quick look back at the history of the periodic table. Dmitry Mendeleev first organized the elements based on atomic mass, and later, on atomic number. Mendeleev originally placed hydrogen with copper, silver, and mercury. Later, he moved it to group 1 with the alkali metals, but there are strong arguments both for and against this positioning. Let's break it down. As scientists developed a deeper understanding of atomic structure, they also proposed different ways to arrange the elements, including, of course, hydrogen. So imagine the periodic table as a complex family reunion where hydrogen is that mysterious relative who just doesn't quite fit in anywhere. Traditionally, we organize elements by their atomic number and look for family resemblances. But hydrogen, it's like the chemical world's ultimate chameleon. Should it hang out with the alkali metals in group 1? Well, hydrogen is univalent, just like alkali metals, meaning it can form a single bond with other atoms. It also shares some similarities in its chemical behavior. Hydrogen forms compounds that are similar to those of the alkali metals. Sounds logical, right? Alkali metals create ionic salts, while hydrogen prefers covalent bonds. Let's look at another option for hydrogen. Maybe it belongs with the halogens in group 17. They're both cool with forming diatomic molecules and making covalent compounds. The problem here is that the atomic term of halogens is different from hydrogens, and the electronegativity trend between the two is counterintuitive. While hydrogen shares some behavior with halogens, its electron structure doesn't quite match. It's as if we're trying to fit a square peg in a round hole. How about placing hydrogen in group 14, above carbon? This idea has been proposed too, since hydrogen's electron configuration is halfway between carbon and silicon. Its electronegativity also fits between carbon and silicon, and it forms compounds similar to methyl groups. While that seems like a reasonable suggestion, it's highly unusual to place a univalent element like hydrogen in a group full of tetravalent elements like carbon. The atomic terms don't line up, so this proposal doesn't quite hold up either. It's about as weird as putting a tricycle in a truck parking lot. Another proposal comes from scientists who argue hydrogen should be a standalone element right in the center of the periodic table, recognizing its truly unique exotic behavior. However, this approach has been criticized by scientists like Seri, who argue that hydrogen should still follow the periodic law. So, even though hydrogen is a bit of an outlier, it might be better off included in the periodic table rather than excluded. One more proposal, made by Labarca and Srivaths, suggests placing hydrogen above both lithium and fluorine, acknowledging its similarities to both group 1 and group 17. But this doesn't solve all the problems, like trends in electronegativity and ionization energy. Plus, hydrogen's ability to form hydrogen bonds across a wide range of strengths is a key feature that doesn't fit neatly into any group. It's like hydrogen is the independent spirit of the chemical world, refusing to be categorized. Hydrogen's special talent is its ability to form hydrogen bonds across an incredible range of strengths. It's like the diplomatic negotiator of the molecular world, capable of forming connections others can't. And let's not forget helium, hydrogen's noble gas neighbor, which has its own identity crisis. Its electron configuration could fit with alkaline earths or noble gases, but its lack of real chemical interactions makes it a noble gas poster child. What makes this debate so fascinating is that chemical classifications aren't immutable laws, they're merely human constructs. We're constantly refining our understanding, drawing and redrawing these chemical family trees. So the next time someone tells you that the periodic table is set in stone, just remember, in chemistry, nothing is ever truly settled. So where does hydrogen truly belong? While there are many proposals, no one has yet come up with a perfect solution. Whether in group 1, 17, 14, or as a standalone element, Hydrogen continues to challenge chemists and physicists alike. What's clear, though, is that its placement is far from simple. Thanks for watching. Until next time, stay curious.